we're solving problem 12 from the 2021 AMC 12B. Suppose that S is a finite set of positive integers. If the greatest integer in S is removed from S, then the average value arithmetic mean of the integers remaining is 32. If the least integer in S is also removed, then the average value of the integers remaining is 35. If the greatest integer is then returned to the set, the average value of the integers rises to 40. The greatest integer in the original set S is 72 greater than the least integer in S. What is the average value of all the integers in the set S? So for this problem, we can set variables to make things easier for us. For the lowest integer, set lowest to L, greatest to G, and sum to be Z. And number of integers is just n, so number n. Then we can start interpreting these statements. The first one says if the greatest one is removed, so basically Z minus G, and then divide by the total number of integers left minus 1. The arithmetic mean is, well, this is 32. This is just the arithmetic mean. Total sum over number of numbers. Second one, if least is also removed, so you subtract the greatest and the least. And then from the numbers, you have to subtract 2 because you're removing two numbers, the greatest and the least. This rises to 35. And then finally, we get if the greatest integer is returned, so Z minus L over n minus 1 is 40. We also get that the greatest integer in the original set is 72 greater than the least integer in S. So the greatest number is equal to the least plus 72. First thing we can do is, well, we can, so there's something we can see here, although it might not be easy. We want to multiply all of these like denominators out. Let's do this first one. Z minus G is 32n minus 32. We can see that you can plug in the value of G into this equation to get that Z minus L is 32n plus 40. Now we already have an equation for Z minus L when we multiply this out. Z minus L is equal to 40n minus 40. We do this, the whole reason we plugged this in was to get a Z minus L to solve for one variable and then one by one solve for the rest of them. So since these are all Z minus L, we can do 32n plus 40 equals 40n minus 40. Those are the two equations that equal to each other. You add 40 to both sides, get 80, subtract 32n, you get 8n. So 8n is equal to 80, n is equal to 10. We have already the total number, which is 10. That's good. Now we just want the greatest and the least. So how, you may ask, do we compute this? Well, we can use the second equation actually. This yields us Z minus G minus L is 35 and minus 70 when we multiply it out. Okay, so then we can plug this in again, the G in. So Z minus 2L, and then for the 72, you want to add it over to the other side since this is a negative G, and that would be a negative 72. So you can therefore add 72 to both sides to make it positive. This is 35n plus 2, but since we know n is 10, this is just 352. We can take out Z minus L. because we know what that is. That's 32n plus 40. This 32n plus 40 is 320 plus 40, which is 360. So we get that 360 minus L is 352. L is then equal to 8. We can use a similar process like this to substitute L equals 8 in this equation to get that Z is equal to 368. We then have the total number of, like, the total sum of, the sum of the positive integers and our number of positive integers. So we can then divide them. 368 over 10 is 36.8, or the average for each positive integer, and is our answer.